I've got another rational inequality up here, and this one's going to be a little bit more challenging because as you can see, the right-hand side isn't 0 to begin with. So the first thing I want to do is move that over. So I'm going to subtract 3 over x minus 1 from both sides. So we'll have 2 over x plus 2 minus 3 over x minus 1. Can't combine those as they are because they're fractions with different denominators. But now the right-hand side is 0. Okay, now that's nice, but the two pieces are connected by subtraction, and that's not good enough. Because when I'm comparing to 0, we're talking about the sign of things. We're looking for where the left-hand side is positive. But as long as these pieces are connected by subtraction, knowing the sign of each piece doesn't necessarily tell me the sign of the entire left-hand side. If this is positive and this is positive, I can subtract a positive from a positive and get a positive, but I can think of other examples where I would get a negative. Okay. Now, in some cases, if this is positive and this is negative, so it's a positive minus a negative, I would know that the whole thing was positive. But if I can get it so that everything's connected by multiplication and division, then in every single case, if I know the sign of the individual parts, I know the sign of the whole. So that's what I want, which means I'm going to need to do that subtraction and combine this and to get one fraction. Now to do that, I'm going to need a common denominator. Least common denominator will just be the multiple of those two denominators, or the product of those two denominators. So I'll multiply this one by 1 in the form of x minus 1 over x minus 1. Since I'm only doing that to just this fraction, the only thing I'm allowed to multiply by is 1, I like to write in that that's 1 because that forces me visually to double check that I'm actually multiplying by 1, which will change the way this looks without changing its value. I'm going to multiply this piece by x plus 2 over x plus 2. That's another form of 1. Now, some of you might have thought, couldn't we just clear the denominators by multiplying both sides by x plus 2 times x minus 1? That's probably what I'd do if that were an equal sign. But I can't do that when it's an inequality. Because when you have an inequality, if you multiply by a positive, you preserve the inequality. If you multiply by a negative, you have to reverse the inequality. And if I multiply by something with a variable in it, I don't know if it's positive or negative. So I don't know what inequality to use. So I really do need to just get myself a common denominator and get this as one fraction on the left. Okay, so on top here, I'm going to distribute that 2. So we'll have 2x minus 2 over, I'm going to keep the bottom in factored form. Okay, because I know ultimately I want to have the top and the bottom factored. I need to multiply out the tops so that I can combine like terms. But the denominators are going to be the same. So I'll just keep those in factored form. And here I'm distributing that 3. So I'm subtracting 3x plus 6 over that same denominator, x plus 2 times x minus 1. And I want this to be bigger than 0. Okay. Now, I do need to be very careful if it's a subtraction problem because I'm subtracting this whole thing. So on top, we're going to have 2x minus 2 minus the quantity 3x plus 6. I'm going to need to distribute that negative as well over x plus 2 times x minus 1 bigger than 0. So, let's see, that's 2x minus 2 minus 3x minus 6 over x plus 2 times x minus 1 bigger than 0. Now I'm ready to combine like terms on the top. 2x minus 3x is going to give me a negative x. Negative 2 minus 6 is a negative 8. And then on bottom we've got x plus 2 times x minus 1. And we still want to know where this thing is bigger than 0. Okay, at this point I've got the top and bottom in factored form. I'm viewing that top as just a single linear factor of negative x minus 8. So I can draw my number line. Again, I like to start with the numbers that make the bottom 0 because I know automatically they're not going to be included. So If x is negative 2, that would make the denominator 0. So I'm going to have an open circle there. If x is 1, that would make the denominator 0. So we'll have an open circle there. Now I can look at the top. If negative x minus 8 is 0, if I add that x over, I'm going to get x is negative 8. Okay. Now, should that be an open circle or a filled in one? Since it makes the top 0, it makes the whole fraction 0. But I don't want to include that because this was a strict inequality. So this one will also be open, but for a different reason. These two are open because they make the left side undefined. This one is open because it makes the left side equal to 0, and I want it to be strictly bigger than 0. Okay, so now I can pick some test numbers and test the sign of this expression on each of these intervals. So I'm going to just record, we've got negative x minus 8, we've got x plus 2, we've got x minus 1, and then we've got the overall sign. To the left of negative 8, I'm going to try negative 9. Now be careful here. This is the opposite of x. So the opposite of negative 9 would be positive 9. Minus 8 would be positive. Negative 9 plus 2 would be negative. Negative 9 minus 1 would be negative. 1 positive and 2 negatives connected with multiplication and division is going to make that positive. All right, between negative 8 and negative 2, I'll just try negative 3. The opposite of negative 3 is positive 3. Minus 8 is negative. Negative 3 plus 2 is negative. Negative 3 minus 1 is negative. 3 negatives are going to give me a negative. Between negative 2 and 1, I'm just going to plug in 0 because I can. That's going to give me negative 8, which is negative. Positive 2, which is positive. And negative 1, which is negative. So 2 negatives and a positive will make that positive. And then to the right of 1, let's just try 2. So the opposite of 2 minus 8 would be negative. 2 plus 2 would be positive. 2 minus 1 would be positive. 1 negative and 2 positives is going to make that negative. Okay, now I look at what I wanted. I wanted bigger than 0. That's positive. So I'm going to just shade the portions that I marked as positive. That's a picture of my answer. And then we were going to give our answer in interval notation. So it would be the interval from negative infinity to negative 8, union negative 2 to positive 1, parentheses around all of those endpoints. Okay, next I'm going to have you try one. Again, I've chosen one of the assigned homework problems for you to try. I'm going to put it up here on the board, but you should try this before you tune into the next video, and then we'll go over it together in the next video. So it's question number 71 from the homework. It's 2x over x minus 2 less than or equal to 2. So once again, we don't already have a 0 here. You're going to have to subtract over that 2. Remember that you can write 2 as 2 over 1, so that you can write it as a fraction, so that you'll be able to combine it with this fraction once you get a common denominator. Okay, so have fun with that one, and we'll go over it together in the next video.